Example 4. Well, given that the line TC is a tangent, okay, so from the diagram, hopefully we'll realize that TC is the tangent to the circle on the right, okay, or in other words, the smaller circle. And what we want to do is we want to prove that TA is parallel to CB, okay? So in order to do this, right, well, given that angle TAS, right, this angle over here is alpha, okay, and we can start immediately playing around with this piece of information, right, and as far as I can tell, if T to C is a tangent, T to S is a chord, alpha is the angle subtended on the circumference by the chord TS. The angle that is made between the tangent TC and the chord must therefore be the same as alpha. So in other words, angle CTS must be alpha, right? So angle CTS must be equals to alpha because alternate segment theorem, okay? Alternate segment theorem. So with this, if I know that angle CTS is alpha, if I now consider the circle on the left, right, we've got a cyclic quadrilateral CTSB. So we should know that opposite angles of the cyclic quad are supplementary. So in other words, if angle CTS is alpha, then angle CBS must be 180 degrees minus alpha. Okay, so angle CBS is going to be 180 degrees minus alpha. And the reason for that is because they are the opposite angles, okay, of cyclic quadrilateral CTSB, right? So that's what we have over here. Now with this, we should be able to see that if I consider, right, this part from C to B, B to A, and A to T, if I look at the two cointerior angles, right, angle CBS and angle SAT, they're clearly cointerior angles. And if I add these two angles together, the sum is quite clearly 180 degrees. So if I know that the cointerior angles are supplementary, then that clearly tells me that CB and TA are parallel because cointerior angles are only supplementary given parallel lines. Okay, so if I put that down in writing, angle CBS plus angle SAT is quite clearly 180 degrees. And this clearly tells us that CB is parallel to TA because cointerior angles, right, cointerior angles are only supplementary, right, given parallel lines. Okay, so that's our proof for example 4.